Hello, we are Team 3, and we'll be presenting on the analysis and redesign of a manual meat grinder. Meat grinders are used to process meat for various grinding and stuffing applications. A key feature of this tool are the exchangeable plates for varying meat cuts and sizes. This tool can also be used for fruits and vegetables. Our primary customer group is going to be adults in residential settings. This customer group is more interested in smaller batches of food and a more portable solution that doesn't require electricity for applications such as camping. Our secondary customer group are restaurants and butcher shops, and they're more interested in larger capacities of food and a more industrial and durable application. In terms of functional analysis, the task function here is to grind food, and the primary basic function is to store food and convert the texture. In terms of storing food, we want to contain the unprocessed food, especially for a larger capacity for our secondary customer group. And we also want to prevent spilling. And in terms of converting the texture, we want to transport and break down the food. And some other notes is that we want to facilitate cleaning, enhance portability, and then also prevent blockage within the system.
Here we have a CAD image of a meat grinder disassembled in a way that allows one to see where the parts should go in relationship to one another. These are the two feasible assembly sequences for the product. The auger, cross knife, and grate grinder have to be assembled in a specific order, which is seen in both sequences. The difference between these two is that in sequence 1, the clamp is assembled at the end, while in sequence 2, the clamp is assembled first. This table compares the two assembly sequences based on the criteria listed. Having only one major difference between the two sequences gives them very similar totals, with sequence 1 being the better of the two. Assembling the clamp first creates an inconvenience in handling during assembly, which is why sequence 2 receives a lower score in that category. Both sequences require you to hold and reorient the body when assembling different parts, which is why neither have perfect scores in ease of assembling in parallel and in ease of transferring and handling.
Here is our function component mapping matrix for the manual meat grinder. The matrix shows the relationship between the individual components and the basic functions that were at the end nodes of the FAST diagram. Most of the components served only between 1 to 2 functions with the exception of the auger. This indicates a large potential impact on the grinder if the auger was to be redesigned. The functions transport food and break down food are influenced by many components, which shows that these functions were important considerations when designing the grinder.
This is our bill of materials for the manual meat grinder. For this, we assume that the total production volume would be 200,000 units per year. We also assume that the tooling life would be the same as the production volume. The assembly labor cost is estimated to be $15 per hour. The total manufacturing cost per unit came to $48.10. This is approximately 70% of the retail price of similar manual meat grinders and their attachments.
Comparing the functions for each of the customer groups, the primary being household users and secondary being those who use it for commercial applications, we determined function difference occurs when containing unprocessed food and product enhancement, which is shown by the different components between our two designs. Each of these designs shares the platforms listed on the left. The modules or differences in these designs are the feeder tray and the S-curved arm. The first module is the feeder tray seen in the center of the screen. This tray is easily attached to the neck of the grinder, allowing the user to feed the grinder larger quantities of meat faster. The second module is the S-curved arm. The new shape of this arm allows for greater torque, making the meat easier to grind for the secondary customer group. Delayed product differentiation is essential to keeping the manufacturing process streamlined and efficient. In the first assembly sequence, you can see product differentiation occurs, but there is still a part added after the clamp that is common to both assemblies. By moving this common component to earlier in the series, we are able to streamline this process.